Hello everyone. In today's lecture, we go with the concept of the chapter angle and its measurement. Okay, in that our first definition is here we have to define the directed angle. Here directed angle, very interesting concept it is, and to define this directed angle we consider one ray. Let here OA be the given ray. Okay, we rotate this ray about O till it takes the position of ray OB. Then angle generated in between ray OA and ray OB is the directed angle. I repeat again, here we consider ray OA. Okay, we rotate this ray OA about O till it takes the position of ray OB. Then angle generated in between ray OA and OB is called the directed angle. So here in between I write here theta, and this theta is the directed angle. So remember this point. Okay, here we consider the rotation anti-clockwise. Here we consider the rotation anti-clockwise. If here rotation is anti-clockwise, then angle generated in between ray OA and ray OB is always positive. Is always positive. If our rotation is clockwise, then angle generated in between our given ray is always negative. So remember this point. Okay, here we consider the order pair form of a ray. Let here ray OA and ray OB, alright, given in the order pair form. Okay, here the ray OA, we consider the rotation of ray OA to the ray OB. Then angle generated in between these two is denoted by using here angle AOB. Here angle AOB is denoted by using like this. Okay, so very interesting concept it is. Okay, now in the next point, we compare our rotation. If rotation is clockwise or rotation is anti-clockwise, then angles are same or not. And to define this, we consider one more figure here like this. Okay, firstly here remember this ray OA is called here initial ray, and ray OB is called the terminal ray. Here I write initial ray for ray OA, and for OB we consider here, I write here terminal ray. Here I write terminal ray. Okay, now in next figure we consider the rotation Okay, here in the first figure we consider the rotation anti-clockwise. If rotation is anti-clockwise, then here measure of angle AOB is always positive. Then here in the second figure, if we consider same amount of rotation, and here we consider initial ray as OB. We consider initial ray as OB. Here I write this OB as initial ray. Then for OA we consider here terminal ray. We consider rotation from initial ray to terminal ray. So here rotation is clockwise. Okay, so here we consider here measure of angle BOA. And here if rotation is clockwise, your angle generated is always negative. So in these two figure, measure of angle AOB is not equal to measure of angle BOA. So remember this point. Very important point it is. Okay. Now we go with our next definition. In that we consider the types of the angles. Okay. Let's go with our first point, first definition. Here is for zero angle. Zero angle. Okay. And to define this zero angle, we consider one figure. Okay, so here we consider origin O. Let here A be the given point. Suppose this OA is our initial ray. If here rotation is 0, here if rotation of initial ray is 0, that is it does not rotate. Then here angle generated in between initial ray and terminal ray is always 0. So here this angle is called zero angle. It's called zero angle. And here we denote this zero angle by using your measure of angle AOB is equal to 0 degree. So remember this definition. Now in next we define one rotation angle. One rotation angle. Again, to define this one rotation angle, we consider one figure. Here origin is at O. Okay, then we consider initial ray as OA. Here OA is the initial ray. Then we rotate this OA up to occupy position of ray OB. Suppose ray OB is again here. Ray AOA and ray OB is on the same line. That is OA is here initial ray, OB is here terminal ray. Okay, here one complete rotation means here from OA up to take the position of ray OB, then the angle generated is called here one rotation angle. Here we consider rotation anti-clockwise. If rotation is anti-clockwise, then angle generated is always positive. So here measure of angle AOB is of here 360 degree. Remember this point. Now if here rotation is clockwise like this, if rotation is clockwise like this, then measure of angle is always negative. So here angle is of here minus 360 degree. Here angle is of minus 360 degree. So remember this definition also. Now we go with our next definition. Here we define the straight angle. Straight angle. Again, to define the straight angle, we consider one figure. Here origin is at O. Okay, let us consider initial ray as OA. Suppose here is our B point. If we consider the rotation of OA up to the position of ray OB, and if we consider rotation anti-clockwise, then here measure of angle is always positive, and this rotation is called straight angle. or here angle is called straight angle. Here in this figure, measure of angle AOB here is of 180 degree. Here for straight angle, we consider 180 degree if rotation is anti-clockwise. If rotation is clockwise like this, okay, if rotation is clockwise, then measure of angle is always negative. So here measure of angle is a minus 180 degree. So here for straight angle, we consider the measure here 180 degree or here minus 180 degree. So remember this definition also. Now we go with our next type. Here is right angle. Right angle. Again, to define the right angle, we consider one figure. Okay, suppose here is our point A and this is here ray OA. Okay, here the right angle means 1/4 of the one complete rotation angle. 1/4 of the one complete rotation angle, and this is right angle. 1/4 means suppose here B is here. Okay, so angle AOB is the right angle. If we consider rotation anti-clockwise, here measure of angle is 90 degree. If we consider the rotation clockwise, then here measure of angle is of here minus 90 degree. So here for right angle, we consider 90 degree or here minus 90 degree. So in this figure, measure of angle AOB is equal to here 90 degree or here is minus 90 degree. So remember this right angle also. Now we go with our next definition. In that we consider angles in standard position. Angles in standard position. Okay, so here I write angles in standard position. Angles in standard position. Again, very important definition. It is here to define the angles in standard position. We consider one figure. This is our x-axis, this is y-axis, here origin is at O. Here in the angle of standard position, here vertex is at origin O. Vertex is at origin O, okay, and the initial ray is along the x-axis. Initial ray is along the x-axis. Okay, let us consider here is our ray OP. Okay, if we consider rotation anti-clockwise, here we get angle XOP. Then we consider Q. Here let us consider the ray OQ like this. Here is our ray OQ. We consider here angle XOQ. Then suppose here is our R. Consider the ray OR like this. Okay, then we consider here S. Suppose S is here, we consider the ray OS. Okay, so in this figure we consider ray OA, OQ, OR and OS. Okay, here in the angle of standard position, initial ray is always along the x-axis. Always along the x-axis. So here angle XOP is the angle in standard position. Since here initial ray is along x-axis and here vertex is at origin O, then we consider another angle. Here angle is XOQ. Again, in this angle, initial ray is along x-axis and vertex is at origin O. Okay, then we consider third angle. Here angle XOR. Here again, initial ray is along x-axis. Then in last, we consider angle XOS. In this also, initial ray is along x-axis. So, these all angles are in standard position. These all angles are in standard position. So, remember this point. Now, here we consider another angle. Let us consider angle POQ. If we consider angle POQ, here initial ray is not along the x-axis. So this is not standard angle. Let us consider another angle. If we consider angle POR. In this also initial ray is not along the x-axis, so this is not a standard angle. So remember this point. Okay, now we go with our next definition. In that we consider angle in a quadrant. Angle in a quadrant. Again, to define this angle in a quadrant, we consider the same figure. Okay, so in this figure we consider, or here in the angle in a quadrant, we consider the standard angle. That is directed angle in a standard position. We consider directed angle in a standard position. So, directed angle is said to be in a particular quadrant. I repeat again, a directed angle in standard position is said to be in a particular quadrant if its terminal ray lies in that quadrant. So here we consider our first angle. Here given measure of angle XOP. We know this angle is in standard position. Here to define the quadrant, we consider the terminal ray. Here terminal ray is OP. This ray OP is in first quadrant. So this angle also is in first quadrant. Okay, so this angle is in first quadrant. Next, here given measure of angle XOQ. Here terminal ray is OQ. Here OQ is in second quadrant. Okay, so here this angle is also in second quadrant. Then we consider next angle. Here angle XOR. This angle is in standard position. To define the quadrant, we consider the terminal ray. Here terminal ray is OR. This OR is in third quadrant. So this angle is also in third quadrant. And in last, here we consider angle XOS. Here this angle is in standard position. And here the terminal ray lies in fourth quadrant. So this is in here fourth quadrant. So we define the angle in a quadrant. Now, our next important definition is for quadrantal angle. Is for quadrantal angle. Quadrantal angle. Here to define the quadrantal angle, we consider one figure. This is our x-axis. This is y-axis. Okay. Here vertex is at origin O. Here to define the quadrantal angle, we consider the standard angle, that is angle in standard position. So the directed angle in standard position is said to be quadrantal if its terminal ray lies along x or y axis. I repeat again. Directed angle in a standard position is said to be quadrantal if its terminal ray lies along x or y axis. X or y axis. Now here we consider some points. Suppose here on x-axis we consider point A. Here in y-axis we consider point B. Then here in negative side of x-axis we consider C, and in last here we consider D. Okay, here measure of angle. Here measure of angle XOA is said to be quadrantal. Why? Since its terminal ray, that is OA, lies along x-axis. Okay, next here measure of angle XOB is said to be quadrantal. Okay, why? Since its terminal ray OB lies along y-axis. Similarly, we consider measure of angle XO, here C is quadrantal since its terminal ray, that is OC, lies along x-axis. And in last, here angle XOD is quadrantal since its terminal ray OD lies along y-axis. So these four angles are quadrantal. These four angles are quadrantal. Now we go with our last definition and is for coterminal angles. Coterminal angles. Okay, last is here coterminal angles. Coterminal angles. This is also very interesting definition. Here we consider the directed angle. We consider the directed angle having the same amount of rotation, in initial ray and terminal ray. Okay, let us consider one figure to define the coterminal angle. Suppose OA is our initial ray, then here OB is our terminal ray. Suppose this angle is of 60 degree. Okay, if we consider anti-clockwise rotation, suppose this measure is of 60 degree. And here we have to define the coterminal angles. Here in this figure we consider same amount of rotation. we consider different amount of rotation having the same position of, I repeat again, we consider different amount of rotation having the same positions of initial ray and terminal ray. Here first angle is of 60 degree. If we consider another rotation, suppose here we consider one complete rotation up to this ray OB like this, then we get angle. Here we consider one complete rotation. We know one complete rotation is of 360 degree, and from 360 degree we go another 60 degree. So 360 plus 60 is here 420 degree. Here we get angle of 420 degree. Okay, then if we consider the clockwise rotation in between initial ray and terminal ray, okay, suppose this rotation is like this. Okay, if this rotation is clockwise, then the measure of angle is of here we get minus 300 degree. This rotation or here angle is minus 300 degree. Okay, so here in the same position of initial ray and the terminal ray, we get the different angles. We get the different angles. Here we get 60 degree, then 420 degree, then here minus 300 degree. So these angles are here coterminal angles. These angles are here coterminal angles. So remember this point. Okay. Now here we consider one note. Here if the two directed angles are coterminal, then difference between the measures of directed angle, difference between the measures of these directed angle is always multiple of 360 degree. Is always multiple of 360 degree. Okay, let us consider some examples depending on these coterminal angles. Example, determine which of the following pair of angles are coterminal. Okay, here in first pair we consider angles. Here 210 degree and second is minus 150 degree. Now to check whether given two angles are coterminal or not, we consider the difference in between these two angles. Okay, so here we consider the difference in between 210 degree and second is here minus 150 degree. We know here 210 degree, then minus of minus is plus. In next we have 150 degree. We know 210 plus 150 degree is here 360 degree. Okay, then here we get I write this 360 as 1 into 360 degree, 1 into 360. So this difference is a multiple of 360 degree. If we get multiple of 360 degree, here we say 210 degree and minus 150 degree are coterminal. These two are coterminal. Okay, so given angles are coterminal. Given angles are coterminal. Let's go with second example. Here in second we consider minus 180 degree and next is here 540 degree. Minus 180 and 540 degree. Okay, again to define or we have to check whether here these two are coterminal or not, and to check this we consider difference in between these two angles. Okay, so here given minus 180 degree, then we consider difference, so minus 540 degree is equal to here we get difference as minus 720 degree. Here we get minus 720 degree. I write this minus 720 degree as minus 2 into 360 degree. So this measure is multiple of 360 degree. If we get multiple of 360 degree, here given two angles are coterminal. Therefore, given angles are coterminal. Let us consider one more example. Here in third, we consider 360 degree minus 30 degree. Okay. Again to check whether this pair of lines coterminal or not, we consider difference in between these two angles. Okay, so here we consider 360 degree minus of here minus 30 degree. This is equal to here 360 degree. We know minus of minus is plus 30 degree. We know 360 plus 30 is 390 degree. This 390 degree is not multiple of 360 degree. Okay, so here given two angles are not coterminal. Therefore, given angles are not coterminal. So in today's lecture, we define the directed angle, then we consider the different types of the angles and some examples of coterminal angles. Thank you.